All right, so this is the Unit 5 test review. So we'll check out number one. Number one says, what is the value of the fourth root of 234 to the fourth to the nearest tenth? So we can go ahead and just kind of cancel these out, and we'll end up with 234. So that's all we have to the nearest tenth. Remember, 4 is an even number, so it could be positive or negative 234. This one's a little bit weird in that in this case, since this fourth is actually on the inside, technically if we really want to, we would have to make this a positive number, and the fourth root of a positive number would then always be positive. So you're not going to lose any points if you forget a plus minus on this one. You don't need a plus minus on this one on a little technicality, which is kind of fun. For part B though, no such luck. Here, this is an even root. This is a second root. So since this is even, we do need the plus or minus. And then we've got 10.1. Now, we might not know 10.1. If we don't know 10.1, that's okay. We can throw it in the calculator. So we can do square root of 10.1. And we get 3.178. Let me make sure I type that in right. It is 10.1. So 3.178, but it says the nearest tenth. Tenth means one decimal place. So let's take that to one decimal place, which would be 3.2. So we put in 3.2. And again, remember that plus minus is because we've got an even root here. The reason we don't do the even root on this one is because we're going to go to the fourth power, and the fourth power will automatically make it a negative into a positive at that point. If you want to use Desmos, you can use Desmos on this one too. We could do a square root of 10.1. We get the same answer. So that's it for number one. All right, for number two, we need to simplify. So to simplify the expression, what we're going to do is we're going to split this up into two parts. So we're going to do square root of a to the 8th over square root of b to the 12th. And then we have to remember that a square root is kind of like a 2. So what we're going to do is turn these into fractions. A to the 8 over 2, because we're going to make the 2 the denominator. Index is going to become the denominator. Over b to the 12 over 2. And then when we reduce these, 8 divided by 2 is a to the 4. 12 divided by 2 is 6. We get b to the 6th. And kind of like part A, even though this is a little 2, we should have a plus minus. Technically, you don't need the plus minus on this one either. You could put it in there. I would put the plus minus on this one. Reason being is they don't give us a little bit of extra information to say that, we're not using any sort of crazy imaginary numbers where some imaginary number to the 8th power ends up being -1, or some value to the 4th power ends up being -1 in our answer. So since we have the variables here, we do actually want the plus minus. Again, I'm not going to be too harsh on this one if you don't have the plus minus, if we're in the same situation with the variables. For number 3, we have to multiply these ones together. So to multiply these ones together, what we're going to do is take our outside piece and we're going to distribute. It looks a little bit weird because it kind of looks like we're distributing backwards, but remember, we're just distributing outside the parentheses to inside the parentheses. So this is going to be 2 square root of 12 times 3, because we don't multiply inside the radical and outside the radical, minus square root of 75 times 3. All right, so nice thing about this one is if I try it out, I'm going to get 36, and I do know that the square root of 36 is 6, so that seems pretty reasonable. 2 times 6 is 12. For this one, if I multiply through, I'm going to get 225. And I actually know square root of 225 is 15. So I'm going to get -3. So this one works out. If it works out, you can just type it into a calculator. So let me type it into Desmos and see if it works out. So we've got parentheses 2 square root of 12 minus square root of 75. So I'm going to put the parentheses outside here, and we're multiplying that by the square root of 3. And it turns out, yeah, that does work out. We can just type it right in. Same deal with the TI. If we want to type it in, we can. 2 square root. So I forgot my parentheses. Let's go all the way back. Second insert those parentheses. Square root of 12 minus square root. So second square root of 75. So I have to go parentheses, and then times the square root of 3. And it turns out we get -3 also that way. So again, not too bad. If you wanted to do it by hand without the calculator, or if it didn't work out, you may have to break these down. The way I'm just going to break down one of them, I'm just going to break this one down, because whatever this is going to break down into is going to be 75 times 3, which was 225. But then 75 breaks down into 25 times 3, which breaks down into 5 and 5. And since I'm going for a square root, I'm going for pairs here. So that's going to be 5 times 3. And 5 times 3 is 15. So again, if they didn't work out well, you would have to break it down like that. But that's what we got for number 3. For 4, we have to find out which is equivalent to m minus 1 over square root of m minus 1. So this one's a little bit odd. If we were just looking at that one, first thing we would do is we'd say, all right, this is like a regular division problem. For division problems, the goal is to get the radical out of the denominator. None of these have a radical in the denominator, so I can't get rid of any of the choices right away. But to do that, I'd multiply by the conjugate. So square root of m plus 1 over square root of m plus 1. When I do that, up top, we do have to do the double distributive property. So m times square root m plus 1 minus 1 square root m plus 1. This is going to give us m radical m plus m. Oops, let me get my arrows in there, because I'm distributing here. And I'm going to distribute again this -1. So I'm going to get minus radical m. And then minus 1. So this doesn't really look very good. Because it doesn't look like anything here is going to cancel out. So it looks like things are not going to go very well. Well, let's see what's happening on the bottom. On the bottom, if we multiply these through, we know it's just going to be the first one squared and the second one squared. So it's going to be m minus 1. So this seems kind of odd. But now we have to wait and think about this and say, well, wait a second. What if we didn't actually multiply this through? Because if we didn't multiply this through, we would be left with on top m minus 1 square root m plus 1 if we don't multiply it through. And so it turns out the trick on this one is to actually not multiply the top. We actually don't want to distribute the top. So instead of just jumping right in, because look at this, those two will cancel right out. So that leaves us with the answer, square root m plus 1. So a little bit tricky on that one. But that's kind of how you would probably approach that question. There is a faster way to approach the question. The faster way to approach the question is to realize that m minus 1 is a squared minus b squared, and just use our tricks from our previous units. So a minus b, a plus b. So m minus 1 actually does factor into square root m minus 1, square root m plus 1. And then we can just cancel out the square root m minus 1 that's on the bottom. So that there actually is a little bit faster way to do this one. We'll still get c. But I'm guessing most people will do it normally. So kind of up here like we did it up here, where we're multiplying by the complex or the regular conjugate of the denominator. So that's what we got for number 4. So that's nice. Again, easiest way to double check, replace the m's with x's, make the graphs. If the graphs match up, then they're the same. If they don't match up, they're clearly different. So you can always compare the graphs. For number 5, function y equals 2 plus square root x is translated 2 units left and 1 unit up. So that doesn't seem too bad. We're going to go left 2. We're going to go up 1. What is the equation of the translated graph? So it looks like we're not doing any stretches or anything. So from the original, y equals 2 plus square root x. I'm going to change this x into 2 units left. So left means I need to go plus 2 inside the radical. And then 1 unit up, I need to go plus 1 on the outside. And this one's a little bit fun because now we can combine like terms on the outside. And we get square root x plus 2 plus 3. So you might think that's kind of weird. That 3 there usually means 3 units up. But look, we're not starting at just square root x this time. We're starting at 2 plus square root x. So we're already going up 2, and then we're going up another 1 for a total of 3. So kind of cool. That's number 5. For number 6, we've got f of x is the cube root of x minus 5. Part A says graph f of x. So what we're going to do is just recognize this is moving us to the right 5. So what we're going to do is just draw our little nice sideways S shape. We'll just go ahead and sketch it in. There we go. What is the domain of f of x? These shapes are negative infinity to infinity for the domain. Because moving it over, I'm still going all the way to the left to negative infinity, still going all the way to the right for positive infinity. What is the range? Same thing. Even though I moved over to the right 5, I'm still going down to infinity, negative infinity eventually. I'm still going up to positive infinity eventually. Again, this is another one where if we want to graph it, we can graph it with our calculators. We've got cube root x minus 5. Remember, if you want to click on the cube root, it's all the way down at the bottom of the functions. Cube root x minus 5. And we can see there's what the graph looks like. That's what we've already graphed. If we want to type it into our graphing calculator, to do cube root, there is a dedicated cube root feature, but I'm going to go the long way. I'm going to type 3, math, and I'm going to pick number 5, because 5 is just the nth root. You could just skip that all and pick the number 4 button. X minus 5. We'll go ahead, we'll graph that, and we can see we get that same sideways S shape. So that's what we got. That's all we got for that one. So that's number 6. All right, for 7, which of the following are real numbers? Select all that apply. So we have to find out which ones are real. So real just means that we get some sort of answer out that's non-imaginary. So for the first one, the square root of a positive is okay. So I'm going to pick that one. Square root of 0, that's just 0. That's okay too. Here I have a cube root. Any odd root, that's always okay. Odd roots are always going to be okay. Now, I could pick them all. I mean, there's no rule that says I can't pick them all. So let me just double check with D here. We have 1 minus the square root of 2. Well, the square root of 2 is bigger than 1. So this ends up being the 4th root of a negative. And since we're going for real numbers, we don't want any i's or anything. We can't pick D. D doesn't work out. That one just won't work. Really easy to do if you want to check them in your calculator. We're going to do 4th root of 1. So this is going to be 4th root of 1 minus square root of 2. And we can see, nope, that is a non-real answer, which is exactly what we want to have. Which of the following are real numbers? Well, this one clearly says it's non-real. So I guess we're all set. I guess that one doesn't work out. We're just going to quit out of that because it didn't work. If we try throwing it into Desmos, we need to go to our nth root, 4th root, 1 minus square root of 2, undefined. So again, undefined in Desmos is probably going to lead to an I. It could lead to something a little bit weirder, but we're not going to pick that one either. So that's what we got. So that's what we got for 7. All right, for 8, we're given the volume of a sphere. Find r to the nearest tenth of a meter when v equals 10 meters cubed. All right, so since we're finding r, goal here is just get r by itself. So let's go ahead and get r by itself. To do that, I'm going to multiply by 3/4 both sides, because that'll cancel out the 4/3. So 3v over 4 equals pi r cubed. I can divide both sides by pi. That's like multiplying by 1 over pi, so the pi's will cancel here. So 3v over 4 pi equals r to the 3rd. To get rid of this 3rd, I need to cube root both sides. And now I'm actually going to plug in the 10. So now I'm going to plug in 10. The m to the 3rd power, that's a unit, so you don't plug anything in for that. We're just going to plug 10 in for v. So the cube root of 3 times 10 over 4 pi equals r. And this doesn't look like it's going to come out nice, so this is one where we're just going to throw it to the calculator and see what the calculator gives us. So cube roots. So this time I'm going to use the dedicated cube root button. It's kind of nice. And we want a fraction. Nice fraction. That is 3 times 10 over 4 pi. So 3 times 10 over 4, and pi is right here. 1.336. How many decimal places are we asked for? Nearest tenth of a meter, so that's 1 decimal point, so 1.3. So R equals 1.3. It's in meters, so we can put it in meters if we want. We can do the same thing in Desmos. We can go ahead and type that in. This is going to be a cube root of 3 times 10 over 4 pi. We can see we get 1.336, the exact same answer. For this one, if we actually wanted to, we can actually graph y equals 10 for the original, and then we could graph the other side, 4 thirds pi x to the third power. And what we would want to do is find out where these two things cross. Let me actually turn on the nice graph. And we can see right there they cross at 1.337, which is this decimal rounded up. So we can actually solve this one graphically. If we want to solve this one graphically, and you can do this in your TI calculator as well, if you'd rather solve it graphically than with a little bit of simple algebra here. But two ways to do it. Again, that second way to do it, if you want to do it with the graph, is recognizing with the original equation, it would be 10 equals 4 thirds pi r cubed. And we would graph one side, the other side, and they would connect here. So you can do it algebraically, you can do it graphically, a couple ways to do it. All right, for number 9, we need to multiply. This one doesn't look like it's too bad. It does say multiply, so I feel like if you want to throw it in the calculator, I feel like we could throw it in the calculator. These are some kind of weird fractions, so I think Desmos is going to be my go-to on this one. 1.5. Interesting. So how do we put that in? Maybe 1 plus 1/2 times the square root of 1 plus 7/9. I'm getting 2. That's kind of an interesting answer. What do we get if we do it this way? 1.5 for 1.5 times the square root of, and there's actually, forgot we actually can just put it in as a mixed number here. 1 and 7/9. That looks nice. I'm actually going to put the first part in as a mixed number too. Okay, I'm going to delete everything. Let's try it again. 1.5, 1 and 7/9. All right, so we want 1.5 times the square root. I'm picking option 2 for those ones, as you can see on the bottom of the screen there, 1 and 7/9. We get 2 again, so that's kind of weird. We're getting 2. That doesn't look like that's supposed to give me a normal number. So why is that giving me 2? Why am I getting 2 as the result? Well, it turns out if I turn these into fractions, we're going to get 3 halves, and then we're going to get the square root of 1 and 7/9 is 9 plus 7 is 16 over 9. And what we want to do is actually break this up. 3 times square root 16 over 2 times square root 9. So 3 times 4 over 2 times 3. I'm going to be super lazy and just cancel my 3's out. I'm not even going to multiply. 4 divided by 2, it's not 8. 4 divided by 2 is 2. And that actually gives me the final answer. So we can actually do this quite quickly without a calculator. Kind of a fun one because it looks like it's not going to work out nice, but it actually comes out very nice. So that's what we got for number 9. For 10, which of the following is a decreasing function? I mean, this is going to be a nice little function question. It's going to be C. We can just look at it and see that this negative sign, remember negative sign in front of the square root, is going to flip it. So instead of going like this, we're going to go this way, and that's going downward. So I already know that that's a decreasing function. That's pretty quick. Now you might think, well, wait a second. B also looks like that. But with B, remember, we can't really do anything with this negative right here in front of the X. We'd have to do it like a weird GCF out of that. So it turns out with this one, we're actually flipping, again, horizontally and then vertically. So we're going from this to this, then to this, which I guess I would have picked by arrow. No, let's go back the other way. I had the arrow the right way. Someone would want to flip it upside down like this. And this is actually increasing because as we go to the right, we're actually going up. So it's not going to be B. A is just a regular square root. So A is pretty quick. A is just looks like that. So that's not going to work out. That's increasing. And then D is a cube root function. Cube root function, like we kind of saw in an earlier problem, we're not going to pick that one either. That's going to increase as well. Easiest way to see it, though, probably just graph them all out. So I'm going to go into Desmos and just graph them all out. So square root x minus 2. Oops. I don't really want you guys anymore. Square root of x minus 2. The second one is E is negative 2 minus x. Negative square root 2 minus x. Third one is 2 minus square root x. And the last one was a cube root of x. Let me double check to make sure those are all right. Look like they're all good. I'm going to go home so I can see them all. Well, can I see them all? 1, 2. Oh, yeah, the blue and the black kind of overlap. All right, so if I look, blue, as I go to the right, I'm going up. It's not the blue one. Goodbye, blue one. The black one, as I go to the right, it's going up. It's not the black one. Goodbye, black one. The purple one, as I go to the right, I'm going up. Not the purple one. Goodbye, purple one. And the last one, the red one, as I go to the right, I am going down. And that is the answer that we picked. So we can definitely graph these out and look at them too. A little bit longer than if we just think about it, but whichever way helps you get the right answer, it's probably the better way to do it. So for 11, now we got a composition. So for our composition, remember the idea here is we're going to plug G into F for the X. So I'm going to take this part for G and plug it into this part for the X. So that means that F of G of X is going to become, or I guess F of G, since it didn't say of X, because we're plugging it in for X. But F of G is going to become the square root of 1 minus X minus 5. Now I have to remember all of my rules. So there's only 2 domain rules. So the 2 domain rules I need to pay attention to are no negatives in even roots. So I have to make sure this is not negative. So if I don't want that to be negative, that means the top's already positive. So I need X minus 5 to be bigger than 0. Well, greater than or equal to 0, because I don't want it to be negative. So if I add 5 to both sides, I know I need X to be greater than 5. And again, if we think about it, if we put a plug 4 in here, then we'll have 1 divided by negative 1, which wouldn't be very good. But then I also need to remember rule number 2. And rule number 2 is no 0 in denominator. So that means that, just like we did in the previous unit, X minus 5 is not allowed to be 0. If I add 5 to both sides, X is not allowed to be 5. So combining these two together, X is not allowed to be, well, I want to say what X is. So X has to be both greater than 5, but also not 5. That should be greater than or equal to, which is going to get rid of that or equal to sign. So I just need X to be greater than 5. Because if I plugged 5 in, I would get 0. Can't have 0 in the denominator. So I have to also get rid of that. So that's what I get for number 11. All right. For number 12, it says A of x is 1 over x minus 1, which of the following could be A inverse of x. Now, again, if we just kind of think about this one and do this one right away, what we're going to do is just replace the y and the x. So we would rewrite this as x equals 1 over y minus 1. We would put this one over 1, and then we would cross multiply to try and get the y a little bit nicer. So y minus 1 times x equals 1. We're trying to get y by itself, so divide both sides by x. Y minus 1 equals 1 over x. Add 1 to both sides. Y equals 1 over x plus 1. And then I would just look at those and say, well, wait a second, hang on. None of those actually match up. None of those are actually 1 over x plus 1. What's going on here? Well, at this point, I can actually pick the right answer because I know I want 1 over x plus 1. This is not 1 over x plus 1. That's x plus 1. This is a subtraction. This is a subtraction. So I actually can logically pick b from this step. Now, what would I do if I really wanted that to become b? Well, what I would need to do is have these have a common denominator and then combine them as like terms. So in this case, this is 1 over 1. I'm missing the x. So this would be 1 plus x over x, and that's exactly what we get for part B. So we can do it that way. If I wanted to, I could also approach this one a little bit differently, because we know that in order for something to be an inverse, if I plug the inverse in, everything should cancel out and I should just be left with x. So if I really wanted to, I could find a of a inverse of x, and I can plug what I think the answer is in for x. Now again, this might be a little bit complicated because our fraction's probably not going to look very nice, -1. But if this ends up simplifying down to just x, then we actually have the right answer. So if we do try to simplify this, we'll get 1 over, here this is over 1, so I'm going to have to do the same thing I did over here and multiply the top and bottom by x to get a common denominator. So x plus 1 minus x over x. All right, well, the x's are going to cancel. So I've got 1 over x. And to make this look a little bit nicer, I'm going to rewrite this as 1 divided by 1 over x, which is the same as 1 times x over 1, which is x. So again, since that worked out, I'm going to pick that one. That one seems like the right choice to pick. If I wanted to be super sure, I would also need to check A inverse composed with A. I would need to check this one too. But since I already solved this one out, I'm not going to do the second part of the check. I'll let you do that if you feel like you wanted to solve the question that way instead of the way that I did it up at the top. So that's what we got for number 12, though. 13, evaluate the expression when x equals 2 plus radical 3. So again, this is kind of getting at the idea of a composition is just a substitution. So what we're going to do is just plug this in for the x's. So we're going to get 2 plus radical 3 squared minus 4 times 2 plus radical 3 plus 1. All right, well, 2 plus radical 3 squared, if we really wanted to, we could do double distributive property on it. 2 plus radical 3 plus radical 3 times 2 plus radical 3 minus 4, 2 plus radical 3 plus 1. And we could double distribute, so now I'm going to distribute everything. So 2 times 2 is 4. 2 times radical 3 is 2 radical 3. Radical 2 times 3 is 2 more radical 3's. Radical 3 times radical 3 is radical 3 squared. Negative 4 times 2 is negative 8. Negative 4 times radical 3 is minus 4 radical 3's. We still have plus 1. And now it's time to cancel some things out. So I've got 2, 4, 0 radical 3's left. All those are going to eventually cancel each other out. Square root and squared cancel out. And so I've got 4 plus 3 minus 8 plus 1. But that's actually 0. So I guess we just got 0 on this one. All right, works for me. If I want to do it in my TI calculator, this is actually really quick to do in the TI calculator. So the TI calculator really has the advantage here. We know that x is 2 plus radical 3. So I'm going to type in 2 plus square root of 3. And we know we want that to be x. So I'm going to say, hey, store that as x, make that into x. Now x is going to be that number. And I'm literally going to type in the expression they gave. X squared minus 4x plus 1. X squared minus 4x plus 1. Oh, hey, it's 0. Okay, so there we go. So TI, really nice to do a substitution. Again, we can just store our value and then substitute it in later. If we're using Desmos, I mean, we can do it this way too. It's just going to take a little bit longer since I really want to type out 2 plus square root of 3 squared minus 4 2 plus square roots of 3 plus 1. And I can see I get 0 there as well. So The big idea there is to know that what we're doing here is a substitution and treat it like a substitution, kind of like a pre-composition like you would do in Algebra 1. All right, for 14, we got some values of f of x. Find the value of f inverse of 3. So f inverse of 3 means that if this were y, we need to find x. X is 2, and that one's done. So that one's really fast. It's just realizing that if I wanted to find the inverse, not derivative, inverse, f inverse, what I would do is I would then flip these columns. 3, 2, 1, 3, 5, 5. So if I plug 3 into the inverse, I should get 2. So again, remember, inverse, we're just flipping the x's and the y's, or in this case, the inputs and the outputs. So this is what our table would look like if we flipped them. For 15, we got a cylindrical pipe. We have to find the diameter to the nearest hundredth of a foot. All right, doesn't seem too bad. Let's get the volume of the pipe. Volume is pi r squared h. Well, this is interesting because we're given the radius, but that's okay. Because if we find the radius, we should be in good shape. So let's divide by pi h on both sides. So v over pi h equals r squared. We're going to square root both sides to get rid of the squared. So we get square root of v over pi h equals r. But to get the diameter, what I need to do is I need to multiply by 2. So multiply both sides by 2. So 2 square root v over pi h equals the diameter. All right, at this point, now I can put in the v, I can put in the volume. So 2 times the square root of 900 over pi, and I can put in the height. In this case, the height is how long it is, because if we were to stand the pipe up on its side, remember, our height would just look like this. So that's how long the actual pipe is. So pi times 25. And again, that doesn't really look like it's going to come out nice. It might, because 900 divided by 25 would work, but that pi is kind of messing everything up. So let's just throw it in the calculator and see what we get. We got 2 square root 900 over pi times 25, 6.77. All right, nearest hundredth of a foot, 6.77. Let me double check the decimals. Yep, we get 6.77 feet. And there we go. So that's going to be our diameter. That's what we got for number 15. All right, next up then, we got number 16. F of x is 1 minus x, which of the following are true under the domain of x. Select all that apply. All right, so let's take care of the easy ones first. F inverse of f of x equals x. That is tautologically true. That's the definition of it, so it's automatically true. For all x that are in our domain of x, that just has to be true. Pretty cool. If we want to double check our domain and range, again, for x, the only thing we could put in would be positive values. So it'd work out when we then input some of the negative values back. We should get D. A little bit strange. For part A, f inverse is x minus 1 quantity squared. So what we're going to do is flip-flop the x's and the y's. So x equals 1 minus square root y. We'll try to get the y by itself. So I need to subtract 1 from both sides. X minus 1 equals negative square root y. So I have to divide by negative 1. So x minus 1 over negative 1 equals square root y. And then when we square both sides, x minus 1 squared is x minus 1 squared. But negative 1 squared, well, negative times negative makes that back to positive. So it looks like we're good to go. We get x minus 1 squared equals y. Okay, all right, I guess we'll pick that one too. For C, f inverse of 1 equals 4. This means if I plug 4 in here, I should get 1 out. So 1 minus the square root of 4 is 1 minus 2, which is negative 1, which is not 1. So it turns out that one is not going to work. We got negative 1, we didn't get 1. Likewise here, if I plug in 1 for my x value here, I should get 0 as my y value out. 1 minus square root of 1 is 0. That one does check out. So I think I'm going to pick that one also. I definitely like B. This question, there's a little bit of trouble with some of the ideas behind A and D. So just kind of be a little careful with A and D, but B is definitely true. So that's what we got for 16. All right, for 17, we got to solve. So this doesn't seem too bad. Looks like we got one square root. So if we just have one square root, the goal is just get rid of the square root. So we're going to square both sides. Seems pretty reasonable. X minus 7, squared is going to be equal to x minus 5. So let's multiply that out. Again, we're just going to use our tricks to multiply this out to x squared minus 14x plus 49 equals x minus 5. All right, well, we can add 5 to both sides. We can subtract x from both sides. So x squared minus 15x plus 54 equals 0. And so right now we just have a regular quadratic. So now we've got the regular quadratic. We'll just solve it with the t-chart. So we'll do a little t-chart factor. Needs to multiply to 54 and add up to negative 15. Well, that's negative 9 times negative 6. Negative 9 plus negative 6 is negative 15. So that's all good. X minus 9, x minus 6 equals 0. Solve it with the zero product property. X equals 9, x equals 6. All right, so we got our two answers, but remember in this section, we need to double check them. We need to check to see if any of them are extraneous. So let's check. So we're gonna check. So x equals 9, we'll check first. So 9 minus 7 equals square root 9 minus 5. 2 equals square root of 4. 2 equals 2. Yes, that one's good. I like that one as an answer. 6 minus 7 equals square root 6 minus 5. That's negative 1 equals square root 1. We get negative 1 equals 1, which is not good. So we're going to get rid of 6. 6 is extraneous, so we're just going to go ahead and cross that fully out. The only answer here is going to be 9. Again, it's a solve question, so if you want to plug them into your graph, you can definitely plug them into your graph. X minus 7 for y1, radical x minus 5 for y2. Let's throw them in. Let's see what we get. We don't need that one right now anymore. So x minus 7 square root x minus 5. And we could see, yeah, here it's 6. We get 1 and negative 1. So that does mesh with the check that we did. And over here at 9, they do match up at 9. So we are going to match at 9. So I'm pretty happy with my answer. Looks like I checked it with the graph. Again, you can check that with the graphs in the TI calculator as well if you wanted to. I just showed it on the Desmos for this one. All right, for 18, another solve. So this time it looks like it's going to get a little bit more complicated because we've got two different things that have some fractional exponents. So I want to get rid of the denominators first. So if I get rid of the denominators first, these are both 3's, which is really convenient because that means I can just cube both sides. And when I cube both sides, I get rid of those. And I get x minus 1 squared equals x plus 5 to the first power. Now, I mean, I could square root both sides, but I think I'm just going to square this side right now. I think I'm just going to turn this into x squared minus 2x plus 1 using the same tricks from before. Equals x plus 5 because that's x plus 5 to the first. And just like the last one, when we move this over, we're going to subtract 5 both sides. X squared minus 3x minus 4 equals 0. It's another t-chart factor. Multiply to negative 4, add to negative 3. So negative 3 times 1. Nope, negative 4 times 1. Negative 4 plus 1. And so we get x minus 4, x plus 1 equals 0. So solving with the zero product property, again, this is going to be x equals 4, x equals negative 1. And then the last thing we have to do is, again, we still have to check it. So if I check 4, 4 minus 1, so the 2/3 is equal to 4 plus 5 the 1/3. All right, well, if we simplify it down, 3 to the 2/3 equals 9 to the 1/3. Well, that doesn't seem great, but I can do 3 squared, and I will get 9 to the 1/3 equals 9 to the 1/3. So that one will check out. I'm pretty happy seeing it as 9 to the 1/3 and 9 to the 1/3. So I think I like that one. I think I like 4. I think 4 is looking pretty good. If I try -1, -1 minus 1 to the 2/3 equals -1 plus 5 to the 1/3. All right, -1 and -1 is -2 to the 2/3 equals 4 to the 1/3. Now I can square this, and I will get 4 to the 1/3 equals 4 to the 1/3. So it does look like the check. It kind of looks like both of them work. So I'm a little suspicious. So let's go ahead, let's plot them out. Let's see if they actually both work. Let's see if we get two connections, if they connect twice. So x minus 1 to the 2/3. So I'm going to delete this one, and we're just going to do x minus 1 to the power of 2/3. And then the other line is x plus 5 to the power of 1/3. We get 1/3. All right. Oh, yeah. Well, it does look like they cross twice. That does. Okay. So that seems reasonable to get two answers. All right. Let's check my table. Let's see. 4. Yeah, those decimals match up at 4. Those decimals match up at -1. I feel pretty good about that one. So I was not so sure about it, but double checking myself. Well, I guess triple checking myself because I already double checked with the purple. It looks pretty good. I think I'm pretty happy with that one. So again, that's one that we got, and you probably could solve that one with the graph as well. You could probably graph those and find out where they cross, because again, the answer is not going to be the 4 to the 1/3 power or the 9 to the 1/3 power. The answer is the -4 and the -1. So it's possible to do with a graph as well. For number 19, store is going to increase prices by 20% and then give a $50 discount. Purchase prices, let x represent the price in dollars, 1.20x represent the increase, and x minus 50 represent the discount. Which function can the store manager use to find the final purchase prices? So it's very clear that we're going to use a composition here. So let's just go ahead and dump these ones that are not compositions. All right, so let's see. So we have to think about the order here. So it says it's going to increase all the prices by 20%. And then offer a 50% discount. So this has to go first, and this has to go second, because it's and then offers a $50 discount. So now we have to remember the rule with compositions, and for compositions we have to go right to left. So I got to find out which one's first, and remember, firstmost is the one that's on the right. In this case, we're doing increase by 20% first, which is f of x. So I have to pick D because D is happening first. G is not happening first. That's not true, so I don't pick C. So that's what we got for number 19. For number 20, we got another solve one. Like I said before, if we've got two radicals on the same side, chances are you just want to graph this and get out of there. But let's see what we got when we do that. So if we want to graph it, x squared x plus 1. Let's go ahead and graph right there. So square root x plus 1. Didn't get my x in there. That's not good. X plus 1. All right. So square root x plus 1 plus square root x minus 1 plus square root x minus 1. And I want that to equal 2. All right, so if I graph it, I can clearly see that those connect. Looks a lot like they connect at 1. Let's see if they do. Second calc, the intersection. First curve. Now, I can't press enter right now, even if I try, because I'm not actually on the blue curve. So I need to go ahead and press over a bit until I'm actually can see myself on the blue curve. So there I am. press enter for the second curve. I'm going to guess. I got 1.25 actually. So it wasn't 1. It was 1.25 according to the calculator. All right. So that calculator gave me 1.25. What's the other calculator give me? What's Desmos going to give me? X plus 1, x minus 1. So square root x plus 1, square root x minus 1, and then y equals 2. All right, so the other one also gives me 1.25. So it's telling me that the answer is 1.25. Now again, I feel like I should be pretty happy that I did that. I think this is one where if we're thinking about using our strategies correctly, graphing is probably the way to go. If you do like to do everything by hand, well, we're going to go ahead and do everything by hand. So what we want to do is we need to make sure that there's one radical on each side. I can't really square it right now. That really wouldn't help me out too much. So I'm going to rewrite this as x plus 1, and I'm going to subtract this x minus 1. So equals 2 minus x minus 1. All right, because now I can square both sides, which square and square root are going to cancel out. So x plus 1, that's pretty good. Over here, I'm using the a squared minus b squared trick again. So this is going to become 4 minus 2 times 2 is 4. Square root x minus 1 plus, and then I'm going to have this inside piece. So x minus 1. So this isn't looking too crazy, but it is looking a little bit longer than any of their problems. So let's go ahead and do the next thing to do, which is to get everything away from that radical, because now we need to get that radical by itself, because we're going to have to go through the whole process twice. So let's go ahead and say x plus 1 equals 4 plus x minus 1. So 4 minus 1 is 3. I've got another x hanging out, and then I've got minus 4 square root x minus 1. The reason I did that, it makes this a little bit easier to move things over. So I've got x minus x would be 0. That cancels out. That's convenient. That's negative 2 equals negative 4 square root x minus 1. Divide both sides by negative 4. So I get 1/2 equals square root x minus 1. All right, well, this actually looks a little bit simpler, but just like before, to get rid of a square root, we're going to square both sides. So let's go ahead and do that. 1 squared is 1, 2 squared is 4, and I've got x minus 1. I can add 1 to both sides. 1 plus 1/4 would be 5/4 equals x, but 5/4 is 1.25. Check that out. That's pretty cool. Is it true, though? Well, we would still have to do the check if we're doing it by hand. We did on the graph, so we kind of did check with the graph already. But if we check by hand, square root of 1.25 plus 1 plus, and I'm actually going to go ahead and revise this because you know what I'm thinking? I'm thinking that fraction that we got earlier going to be a lot nicer at this point. 5/4 plus 1 plus square root 5/4 minus 1 equals 2. Well, square root, this is going to be 9/4. This is going to be 5/4 minus 1 is 1/4. So this is going to be 3/2. This is going to be 1/2. And 3/2 plus 1/2 is definitely 2. So it does work out. And it is pretty cool that all the fractions work out with that one. So it is a little satisfying if you do all the work by hand. Really cool that you get to the answer that way. But if you're one of the people that just likes to solve them with a graph, I don't blame you. That's probably the fastest strategy on this question. So that's what we got for number 20. All right, for 21, volume of a sphere is given by 4/3 pi r cubed. Radius is increasing at 5 millimeters per second. Function r of t gives the radius in time as time increases in t seconds. We'll say it's 4 times t seconds. Which function gives the volume at time t? So the idea here is we're going to plug 5t in for the r. So if I'm going to plug 5t in for the r, I'm plugging the r function into the v function. So that would be going this way for A. This would be plugging V into R, which is not what we're doing. This is adding and that's multiplying. I mean, those aren't close to being right. So really it's between A and B. And just like we saw with that other shop example, we want to read those from the right to the left. So that's what we got for 21. 22, last question. What is the least value of x such that x, the fourth root of x to the fourth, is equal to x? This is another one where it's kind of hiding some of the words behind it. We want to kind of amend this to say for all x's that are real numbers would probably be a good choice. Because again, there are some crazy numbers out there where we may not get the answer that I'm going to pick, but for the sake of argument for this class, we're only dealing with some of the more normal choices for strange numbers. So x to the fourth equals x. You would think you could just cross these out again and then just pick -1, but hold up, because the fourth root of -1 to the fourth, does that actually equal -1? No, because -1 to the fourth would be 1. And we would actually get 1 equals -1, which is not true. So it turns out, even though it looks like it's one where we could just kind of do that, we actually can't. So that doesn't work out. If I tried 0, 0 is going to work though. So 0 will work. The fourth root of 0 to the fourth is going to be the fourth root of 0, which is 0 equals 0. So that one will work out. The reason it's not no least value of x is because we've already found one that wouldn't work. And then 1 is bigger than 0 already, so there's no point in even going beyond that. So that's kind of how to sub them in for. How is the equation intended to be done? Well, you're intended to think like, okay, if I have a fourth root here, a fourth root is always going to be positive. Oops. Still put in a y there. It's always going to be positive for normal numbers. We'll just say for numbers that we know right now. And again, that's going to give us all right, not positive. Oops. Always non-negative. Got to the end. Almost made it. Always non-negative. All right, there we go. And yeah, so like I said, there are some crazier numbers that do exist where we can actually get some negatives out. We could get some even crazier things. And we've already had a little bit of discussion with that when we talked about the i's. So when we did all the i's, we saw we could get some kind of crazier stuff. But for this one, we're going to consider our numbers to be a little more normal. Even i's would still kind of work out in some instances. But we're going to forget those for now. We'll just pretend that it's for all real numbers. That's it. So that's the entire test review. Went through a lot of calculator tricks. Went through how to do all the questions by hand. It's a big one. There's a lot on this one. I don't think it's going to be as crazy as the last big test. There are a lot of questions, but the intensity of a lot of the solving is not as big as the previous one. And the calculator does help out a lot for this one. So that's it. That's all we got for that one.